average value of a function. Is saying, ready? If you have the same width, how tall would a rectangle be that encloses the same area? Now, there's a distinction between the mean value theorem, which is what we talked about Newton unit from CDX, and the average value of function, which has to do with anti-differentiation. We'll make that distinction on EDF. So, but this is a really good visual here. So you've got this quadratic, 1/2 x squared, and you're in the first quadrant only. And you want the area from 0 to 3. Makes sense? So there's the question. It is the sum, starting at 0 and ending at 3, of all these very thin rectangles that are 1/2 x squared tall and bx long. You understand the question? It's written. If you don't understand what's written there, you're just spinning the wheel. And we could do this on the calculator with numerical derivative, but we don't need to, because it's a user-friendly question. So what happened between this step and this step? And it's a power rule in reverse, which we're anti-differentiating. We're looking at it as if 1/2 x squared is the derivative of what we want. So when we anti-differentiate it, we have 1/2 x squared. We replace, what do I differentiate it? I multiply this 2 out and replace 2 with 2 bigger 1. So when I anti-differentiate it, I'm doing a reverse order of operation. I have the addition first. Of adding -1. I say +1. And then instead of multiplying that value by 1, I multiply by the reciprocal. And that's how you get 1/6 x to the 3rd. And when you verify that, you just check if I differentiate what you got. And see if you got back to the question. So if I take the derivative of this, you get 3/6 x squared, 3/6 is 1/2. So you anti-differentiate it successfully. Now what we want to do, we're going to put in the upper and lower limits. The upper limit is 3, the lower limit is 0. So what would you get? 3 cubed is 27. You get 27/6. Subtract 0 cubed is 0. You have 27/6 subtract 0. 27/6 reduces to 9/2. I don't care whether you reduce it. College Court doesn't care whether you reduce it. What does that mean? It means the shaded area in yellow is 9 square units. 4.5 units squared per shade. Now we look at average value of function. Average value. How tall would a rectangle be if it had the same width and the same area? That's not really complicated. The area is 9/2. The width is 1 foot, is 3. What do you multiply 3 by to give you 9/2? 3 times 20 equals 9/2. Multiply both sides by 1/3. you would get 9/6, which is 1.5. It's the same answer they got here. They said, here's the 9/2, 4.5. Here's the width. What have you got? You've got height times width equals area. So the area divided by the width is the height. So visually, it looks like this. This red rectangle captures the same area that was shaded in yellow. That's what this means. Now, don't let this be complicated. Ready? The average value is this, which looks really more complicated than it is. This is the area from A to B, the height times the width. That's the total area. Then this is the width. B take away A. In this case, it's 3 take away 0. So you're dividing the area by the width and you're getting the height. But instead of writing this B take away A as the denominator in there, they just brought it out from the area. It's the same thing. Now, this is the problem that we started the alpha lesson with, but we didn't deal with it because we didn't deal with average value function. That's problem 49. Right.
I have a question for that. When you put the opposite power rule, it doesn't grade it as the way power planet.
Okay, let's back up to this.
We're just looking at the first step.
Right, I understand what you're saying. Oh. So here's Reynolds' question. When we did the power rule in reverse, and we went from here to there, what happened to the dx? That's the problem.
Yeah.
So the issue is, in this question, this is telling you that the area is the sum of this height times that width. And if we add up the area under the derivative, we get the area of, if we add up the area under that, we would get the area of the function. So that's all this is. We're not, this is the answer to that. So that's the width. We don't need the width anymore.
So the width comes later. We're not going to do the area of the width.
Okay, if you're answering that, yes. Dx represents the width. That means the dx is the instantaneous change. Back to limits. As the rectangle is skinnier and skinnier and skinnier. And what's the area? So we're going to come back to this question about the cosine. But here's what you're trying to understand. And I put it in a table. So just see if you can follow the table. The mean value here is saying these are the 2 points A and B. X of 1, X of 2, the lower the number. In the function, this is the average value. This is the mean value there in the derivative. That's what we did sort of like your commute from CDS. So the average value of the function we're doing now, the area equals the horizontal minus the vertical. What is that? Well, the horizontal is delta x. It's your change in x. Horizontally, which is b take away x. Your vertical height is f of x. So the area is multiply these two together. Delta x is dx. The average value is the height. What do? We divide this thing, area, by delta x, which they wrote is 1 over b times a. Here's the area. And we have, what is the average value and when? When is it taking the average value? We did the same thing with the mean value. So let's look at example 3. We are on page 287. Find the average value of 4 plus a negative x squared. There is a picture in the margin on page 287. You want to know the height of the rectangle. What I have? They're telling you from 0 to 3. So this is going to be the area over that curve, sorry. And this is going to be the width, 0 to 3. So I'm going to divide it into by 3. You're going to listen on the whole choice assessment. People jump to this conclusion. If they're asked for the area, sometimes they find the average. If they're asked for average, sometimes they find somewhere. And those wrong choices are going to be wrong choices you got to choose. You need to understand what's being asked. So, here comes the power rule reverse, which I try to write out here. What's this? This is really 4x to the 0 power. Is anything to the 0 power is 1. So to do the power rule reverse, I replace the 0 plus 1, and then divide by that value. Which is going to end up giving you 4x. And you can verify this from point, because when you differentiate 4x, you get a 4. I understand if you don't walk the power rule reverse the first time, all you have to understand is this. You're doing what you've done through 3.5 months, well, 3 months, and you're just undoing it. So now you got x squared. I replace the order, opposite order of operation, reverse of the operation, replace the 2 with 2 plus 1, and then divide by that together. Then I have plus c. What does the plus c mean? Because it's really a k. It's the k, it's the diagonal round. It's the capital place plus c. It's where you are in the Pringle scheme. You might be the top of the can, you might be the middle of the can, you might be the bottom of the Pringles can. All those Pringles have the same shape. So why undo this? I would be here. Anti-differentiated. 4 plus the negative x squared. We're taking 4x, subtract x cubed over 3. Make sense? Because when I check my answer, root 4x squared, the derivative of this would be 3 times x squared divided by 3. Here's the reduce. Plus some constant. Why? Because when you differentiate a constant, you get a 0. So this thing, this 4x subtract x cubed over 3, it could be that plus 10. Well, first of all, it's not going to matter. You can do that easily. We'll see. It could be plus 50. So when you differentiate, you're going up to a 0. So I put the c in here so you can see what happens. You don't need to do this in May. In November, you need to do it in December. But you understand what the c is doing. So here's what I got. 4x. Take away x cubed divided by 3. I'm going to evaluate that from 0 to 3. Put a 3 in here. In this one. 4 times 3 is 12. Take away 3 cubed over 27. Plus the constant. Subtract. Put 0 in here. Right? 4 times 0 is 0. Subtract 0 cubed over 3 is 0. Plus the c. Well, now you see what happens. You have c subtract c. We're going to add 0. Which gives you 12 take away 27 thirds, which is 9 thirds. All right, we're doing this in one step. 9 thirds. 3 is the area of the curve. Here's a graph like up here. Find the area of the curve, I put it line 1, 0 to 3, get 3. Now what? How tall is the rectangle? I divide by the width of 3, you get a 1. So the rectangle would be 1 tall. Between 0 and 3, we capture the same area. This is what? When does that happen? That's the picture in the book. That happens at root 3. If I put root 3 into the function, I would have 4 subtract root 3 squared. Root 3 squared is 3, 4 subtract 3 is 1. So this is the when. That is the what. The area under the curve is 3. But the average area, the average value function is 1. Because the rectangle is 1 tall by 3 wide, we capture the same area of the picture. So I'm leaving it up here. You need to do this, right? You need to write out the steps, so skip steps in your anti-differentiator and build your table. So we're going to pause the video and send you to problem 11. So the width of this thing is going from 0 to root 3. Here's the function. X squared plus a negative 1, which is what? It's the quadratic shifting down 1. So like x plus y plus 1 is x squared. So when you anti-differentiate this, this goes to x cubed divided by 3. That goes to x. Now look, because you don't have that, you don't have x cubed, take away x. Then anything else you get, so I put these numbers in here. Root 3 in there, and then I take 0 for 0. So put root 3. Root 3 cubed, root 3, subtract root 3. Plus the constant. Subtract, put 0 in here. Now you gotta be careful. Just before 0, the lower limit is giving you a 0. In the example of problem 11, you're not guaranteed to always have a 0. So people get in a hurry, the lower limit 0, I'm not going to substitute that. You had D here, you had like x plus 1 in the parentheses. Well, 0 would generate that. So these two are multiplied to 3 and reduced to that. You have root 3, take away root 3, you have a 0. So the average value is 0. Doesn't matter what you like 0 by. Here's the picture. You're going from 0 to root 3. So put this vertical line at root 3. To say that the average rate of function means this, and I know you can't see this enough, that this area down here and that area up there are the same. And because the area below the x-axis is negative, you add to the area above the x-axis, they add to 0. So then in the table, we would say this. 0 root 3 to the A and B. We calculated 0. But what did we do? We found out if you put a 1 in the original function, x squared take away 1, you would get the 0. So that happens at 1. It has to happen in between the 0. That is the what, this is the when. Okay? So, if you are at home, doesn't matter whether you're ADP or you're an HR, you're dismissed to the exit table. We are going to go over some other things, something else on here. The people in the building, you can watch that on the YouTube page. You can see. Let's go back to this problem. What's the average value of the cosine from 1 to 5? What does that look like? Look like this. Here's the cosine function. That's a 1. Here's pi. And you're saying 1 to 5. 1 to 5, pi's in there, right? And what's the area in here? Add that up and divide it by the width of form to the average value of function is.
So 1 to 5.
Yeah, 1 to 5 is in the question. So what did I do? I put cosine x and y1. And say, now this is the old school way of the output of the old calculator. If we do it this way, you can just do it together in the calculator. Make sure you're in radian mode. Math. Anti-differentiate from 1 to 5. Yes? Cosine x. You can type cosine x here if you want, or you can refer it to y1. Either one. Cosine x dx. What's that going to give you? That's going to give you the area, the net area, the curve. From here to here, these would add up to a negative 1.8. Because more the area curve would be below the x-axis. Except its width is 4. That's the area. If we divide the area by the width, we would get the height. So I look here, and that's choice B. It doesn't really matter what the letter answer is. You understand what you did. We took this thing here. Here I did it in one step. it's negative, or who do I truncate it to 3 decimal places and go with that? Okay? So in summary,